There is a special case in making inference about the difference between two population means when we have matched samples. Frequently in business situations, we can get data where each sampled item has a pair of data values. And this will lead to smaller sampling error because the variation between the sampled items is. We'll work through an example. We have a company that processes documents through two different delivery services, and they want to find out the difference between those two services. In testing, the company sent matching reports to a sample of those two different offices. Therefore, we have matched samples. Because that same report was sent, we will calculate the difference between each pair of samples. We will then use the mean of those differences. That mean of differences will be our point estimator for this mean of the difference between two populations with matched samples. We will call this mean of the two differences D bar. Computing the test statistic, this D bar is 2.7. The formula for the standard deviation of this new sampling distribution, the standard error, is shown here as S sub D bar, for which we get that standard error of 2.9. Using those two values, we come up with our t-test statistic of 2.9. For that test statistic, 2.94 and 9 degrees of freedom, we know that the p-value is somewhere between 0.02 and 0.01. Since this is a two-tailed test, we have doubled the upper tail areas of 0.01 and 0.005. Because this p-value is less than our significance level, we know that we can reject the null hypothesis. We're at least 95% confident that there is a difference in the mean delivery times for the two services. For a t of 2.94, and 9 degrees of freedom, we see the p-value falls between 0.002 and 0.01 from the table. Now, I believe the critical value approach here is a bit more intuitive. For an alpha of 0.05, we are looking at a critical t-value of 0.025 as a two-tailed test. At 9 degrees of freedom, that critical t-value is 2.262. Our t-test value of 2.94 is greater than that, therefore we reject the null hypothesis with the same conclusion.